My name is Frédéric Pujol, and I am the 5GSE support platform project leader. This session today will be dedicated to 5G edge cloud integration. So let's have a look at the agenda for today. Next slide, please. We'll have a first presentation by the 5G Make for EU project. Then we'll have two call to project presentations. So these projects use 5G Edge Cloud. And then we'll have a presentation by T-Systems and a Q&A session at the end of this session today. Next slide, please. Just a few words about our GSE support platform. So we support the European Commission and we play a role as a one-stop shop. So we animate the cluster of 5GSE projects. Next slide, please. We also organize conferences and capacity building sessions, and we support the European Commission in policy conception. Next slide, please. We run 7 capacity building sessions last year, so you can have access to the videos on our 5GSE platform. Today, first session for this year, and we will have a second capacity building session at the beginning of June. So I propose now to go directly to the first presentation for this morning. This presentation of the 5G Make for EU CSA will be made by Dimitri Jungblut, who is consultant at DTCon and is also the project leader for this project, and also Stefan Schnitter, who is managing partner for cloud transformation. Dimitri and Stefan, the floor is yours.
Yeah, Frédéric, thank you very much for giving us the opportunity. And also thank you, Angelo, for organizing everything so well. And a big thank you to the 5GSE support platform for giving us the opportunity to talk today about edge cloud integration and about our initiative, about our CSA 5G Make for EU. And we prepared some slides, a presentation. It's going to be about 20 minutes. I will present it with my colleague, Stefan. And let me just quickly share the slides. Okay. I hope all of you can see the slides.
Yes, perfect. Thank you.
Perfect. Thank you very much. So, as I just mentioned, our CSA is called 5G Make for EU, which stands for 5G Multi-Access Edge Computing for EU. And as the acronym already says, our main topic is the interoperability between 5G and multi-access edge computing and the benefits that basically will drive future data processing, data storage, and data transmission, which means that data will no longer be exclusively processed in specific dedicated data centers, but will be processed closer to the edge network, closer to the user equipment. So this as a very brief introduction. Let me then directly just dive into our initiative. So to give you a very broad picture, 5G for EU in a nutshell, our project duration is 30 months. We just started this year, so right now we are in the ramp-up phase. And we are a consortium of 2 partners, Monarch from the Netherlands, which is a startup very much focused on connected automation, mobility, connected automated mobility, and CITS, and DTCon, which is a managing consultant company located in Cologne in Germany. And 5G Make for EU is funded by the CEF Digital program and is managed by HDEA. And it's a coordination and support action. And our main stakeholders are 5G communities and 5G cross-border corridors, where we actually had yesterday the opportunity to visit a live demonstration of a 5G cross-corridor in the border region between Greece and Bulgaria, which was a very nice opportunity. So we hope to see many of these demonstrations in the future from the projects. Yeah, and our big goal is, of course, to establish a collaborative network between these main stakeholders. So the EU-funded projects, the CEF-funded projects, with the topic of smart communities, and also for 5G corridors. Well, I think here today the focus will be clearly on smart communities. And yeah, what we want to do is we want to develop an interoperable framework, synchronize connectivity across the borders, and also share knowledge and best practices from the projects regarding edge computing. Yeah, and maybe to give you a brief overview from the European standpoint of view. So the big goal, of course, is to have in the future 5G standalone network, which includes MEC as part of the network. Right now, we see that 5G standalone has approximately about 20% coverage of the populated areas. So there is very much work to do. So this data is from the 2023 report on the state of the digital decade. And there you can also find a very the goal of approximately 10,000 secure sustainable edge nodes by 2030. Right now, the report says that this goal is very hard to meet until 2030. And this is basically why our initiative came to life, and why we are aiming to push the development of edge nodes, to push the development of edge computing within EU-funded projects to reach this goal until 2030. Yeah. Then next slide, I would hand over to my colleague Stefan, who will give you a broad overview on edge computing as a whole. And afterwards, after we picked you up from that point of view, I will then make a bit of a deep dive into our project to explain you the structure of our project, and to explain you how our strategy is to reach all our stakeholders in the next months to go. So I would like to hand over to Stefan.
Mm-hmm. Yeah, thanks, Dimitri. I hope you can all hear me well. So if you go to the next slide, please. Thank you. So yeah, I want to give you a bit more like a technology introduction to like what are the main use cases, benefits, and also terminologies around edge, so that you can get an understanding if and in how far this can be useful for you in your projects, in your activities. And just in terms of like terminology, we speak about like compute, storage, networking capabilities in different locations. From public cloud, which is very much centralized approach, to like on-prem and campus private locations. But there are many like gray different positions in between. Yeah, so more central data centers, regional data centers, aggregation locations, things which are integrated to the mobile network, base stations locations, and so on. Yeah, this is the kind of geographical view, but then you have also the, I would say, service view on the right side. Yeah, you have hyperscalers, like provide hyperscale offers providing also edge solutions. Yeah, so this is like a way to extend the public cloud to a more geographically distributed way. You have something which I would rather call a public edge, where you have edge computing capability, which is available freely to everyone, and then something which is more integrated into mobile network, which is something more like a private edge to a certain infrastructure. Yeah? And especially Mac is falling in this middle area. And then you have something which we are not discussing here so much is then a user edge. Yeah, so you have compute capabilities on the train, or in the factory if you have a private 5G network, and you have edge capabilities integrated there as well. Yeah, so there's a broad spectrum of technologies here. If you go to the next slide, Dimi. Yeah, so I think important to understand what are the main drivers. So we are coming from this standard internet-based type of computing workloads, which have a relatively high latency, to use cases where latency plays a role, sub 100 milliseconds up to 1 millisecond type of latency requirements by different use cases. But what I want to highlight is that latency is not the only driver for thinking about decentralized computing or edge. So it's especially also the high data transfer, which has a cost associated. Yeah? So I would say the most successful use cases regarding edge are rather driven for cost, because I mean, data transfer to cloud is quite expensive in many cases. That's why it makes sense to do some pre-processing and not stream like computer vision stuff to the cloud completely. And but also a question of end devices. If you have end devices where you have limitations on the form factor, what battery constraints, so you want to make cheaper end devices, and you kind of outsource some computing power to an edge part. Latency still is, of course, a main driver. So that's the kind of reasoning around it, and that's where you also classify the use cases. And also, I will show you later how you separate the technologies in a way, yeah, so to understand what makes sense in case your use cases. If you go to next slide, Dimitri, please. Yeah, I mean, there's a lot of research use cases ongoing where this kind of drivers are relevant, latency, but also privacy questions. I just wanted to show you a typical way to classify use cases which are already implemented today on the edge side, and you can especially with enterprises classify this in these three categories. Things are related to like collaboration and customer interaction, so like person-to-person interaction type of use cases. Then there's a large area of product engineering, architecture design, which is done in a very different way today and going forward, and edge is playing a role here, but also even like business simulations, where you would probably not have assumed that it's definitely not so much a latency question. And here are just some examples of companies that are working with this today in very different areas. Yeah, more on the like virtual showrooms in Audi, or plant relocations with mixed reality, how to make it more efficient to relocate the whole factory plant, or this whole area of moving real life experiments to a virtual environment. Yeah, doing if you want to train AGVs, you do it in a virtual reality simulation, and you still have some hybrid scenarios where you need some real elements with the virtual elements. That's why having this done in an edge setup is typically what companies are doing, like a BMW case here. Yeah, and if you go to the next slide, looking more from a mobile network point of view, it's also not one size fits all. Yeah? If you are interested in use cases which have a tight integration of 5G and MEC, then it depends on the use case categorization. And there is this enhanced mobile broadband, which is the more general streaming of large amounts of data. There are use cases which are classified as ultra reliable and low latency communications, as URLC, and and things which just have a massive amount of endpoints, which typically is called this MMMTC kind of use cases. And you see there are different architectural options how to do this integration then, and depending if you need real-time or non-real-time type of requirements. And all these architectures are standardized, and you can find them implemented in various networks in various degree of status. So not all of this is really existing. So this was more on the mobile side. I wanted to show you also a little bit what I think is important whenever you think of going in this direction. You think that this is relevant for your work, your use cases, your research. You typically start by looking into the use case that you have, and you need to identify the key drivers. So is it you're thinking about decentralized compute because of the privacy, because of the latency, or because of the efficiency in terms of costs? And then there is a really large amount of technical solutions that I think there's a good understanding how they are linked. So if you say you have a latency play, typically then certain solutions make more sense, or if you have a privacy play, then you definitely want to have something which is decoupled from a hyperscaler type of application. Just to give you, and then there are things which you have a full stack, you have a hardware and software, or there are like software only solutions that you can basically deploy on something which you already exist. If you want to have some kind of edge framework just to deploy on an infrastructure you already own. So there's a quite complex ecosystem of solutions that you would select in this case. I think that was just from my side a quick overview on the technology side. Dimitri, I would hand over back to you to speak a little bit more how we use this in the project and what we are doing.
Yeah, thank you very much, Stefan. This nice overview on the use cases, on the technology itself, a very high level overview on the architecture. And now I want to deep dive again with this knowledge into our project, into our initiative. So as I already mentioned in the beginning, the coordination and support action has two main stakeholder groups, which are 5G smart communities, where we are planning, or where we already have a very close collaboration with the 5G SC initiative, the 5G SC support platform. And there of course we want to derive additional benefits from MEC for these projects, for the CEF-funded projects, in specific areas like healthcare, agriculture, logistics, and so on. For these specific areas, also once again, the 5G coverage plays again a very important role. For example, for areas beyond populated areas, the coverage is not as far developed. Then, of course, use cases like precision farming are relatively hard to be developed there. So this is one of our main goals, to basically talk with the projects, talk with the project coordinators about their development of the project, about their needs, about their best practices, to share this knowledge together with all of you, and to learn how these use cases can really be brought into implementation to develop really a pan-European ecosystem that relies on 5G, that relies on MEC, and that develops specific use cases that will really bring new business models and entirely new markets. And on the other side, of course, we have the 5G corridors, where the big topic is, of course, the cross-border operability, the seamless handover between member states, the operability between different operators, which is a very, very important aspect here. And of course, there are also specific use cases that will be discussed with these groups we hope within our initiative. And if we quickly have a look at some of our very key stakeholders, so this is just an overview of the CEF work projects for smart communities and 5G corridors. Of course, we will also have a look on other projects, on previous projects, also maybe funded by Horizon Europe, like the 5G Croco, for 5G Carmen project, and so on. That already had a view on edge computing, that already described some step towards implementing this technology into the network. And yeah, as you all know, there's of course the third call where a number of proposals, 32 proposals in total, were submitted, and yeah, we hope to hear very soon about these projects. Actually, today we will also hear something from one of these projects, from the number 4 on the left side, the Edge project, which especially in the call 3, there are some projects that also have a clear focus on edge computing, which also shows that the European Commission and the European Union wants to implement this technology, wants to implement this technology to really have its benefits, and to drive a really sustainable future for network connectivity in Europe in the future. And now, if we look on the levels that MEC really wants to analyze these projects, it wants to have discussions with this projects, we will first have the first layer, the uppermost layer, which are the use cases, as I just mentioned. We want to find best practices. We want to find first low-hanging fruits, use cases that can really be run on several architectures, maybe on several standards that already are very heavily in use. And then, of course, we want to derive how these architectures should transform to really have a pan-European open source architecture that can drive these use cases. Then the next level is this MEC architecture itself, where our goal is really to describe the components, to describe where exactly on the edge the data processing should be done for what specific use case, and so on and so forth. And last but not least, of course, very important is the RAN level, the radio access level, which will be also analyzed by our project, of course, with close collaboration with all the other running projects, and also with the big initiatives, 5GSC and GUIDE, where we also have a close collaboration with the CSA. Then to give you a very broad overview how we want to accomplish this and what our deliverables will be in the end. So first of all, of course, it is creating a network, really in close engagement with all the projects to understand their needs, how we can support you, in delivering on your project in the context of edge computing, of MEC. And yeah, to build up a very strong European community that has a very broad knowledge sharing and dissemination of information between these projects, and maybe between other projects where we can learn from, which are not exclusively CEF funded, but could also be Horizon Europe funded, and so on and so forth. Maybe the Digital Europe program has also some very important best practices that we can learn from. And we want to align these initiatives so work is not doubled. And we know that is very important because we have a very big number of different operators across Europe, a different number of use cases for every country. And it's very complicated to really harmonize it, to find a pan-European harmonized architecture that can really drive benefits for most of the countries. And last but not least, this will be the framework development. We want design this comprehensive structure for mobility actors and to even explicitly emphasize cross-border operability, cross-network operator, cross-OEM, and so on. Yeah, so these are basically our 5 pillars, our 5 big deliverables that we promise. And yeah, let's see. We of course we hope with the collaboration with you and your partners this will be possible. And a very quick deep dive into our project structure itself. So it's structured into 4 work packages, where we have first work package, which is dedicated with project management. And then we have work package number 2, which is about community engagement and knowledge sharing. And then we have the 2 more technical work packages. So this is the use case development, which is led by Manoj. They have already a big number of use cases defined, and we will try to find use cases that are very relevant, especially relevant, for example, for smart communities in the different sectors, as I mentioned, this is healthcare, agriculture, logistics, and so on and so forth. And this work package will closely collaborate with work package 4, where we will describe a reference architecture, as I just mentioned. Now, last but not least, our approach is to have 2 different groups within our project. We have our steering group on the right, which consists of 5 members right now that already accepted, which is 5G AA, 6G SNS, Ertico, 5G SC, and Guide. So we will first analyze and harmonized approach between these partners, between in the context of the steering group, to find a nice alignment for a strategic alignment for the next years. And we have also discussions with IPSI-SIS, which we also think that we can learn very much from, and from their approach and from their architecture. Yeah, so there will be also collaboration with them. And on the right, on the left-hand side, you can see the smart community groups and the 5G corridor groups. So these will basically be the projects that we will work with, from which we will try to learn. We want to prepare questionnaires. We want to derive new business models, entirely new markets, maybe even for key technologies like IoT, AI, data analytics, and so on and so forth. And of course, very important for us is that we can support you in your project developments, and that we can really synchronize all the efforts within these projects. Yeah, so that was the overview of our initiative. I would like to thank you once again to giving us the opportunity today to present it. And if you need some more information, you can contact either me, I'm the project coordinator of this initiative, or Paul from Manoj, who will be responsible for use cases in general. So now we're open for questions, and yeah, I would like to thank you for listening.
Thank you very much, Dimitri and Stefan, for the presentation of your CSA and showing how Edge can bring benefits of 5G SC. But we'll take questions at the end of the session, and I invite all attendants to put questions in the chat, in the WebEx chat, and so we'll have the Q&A session at the end. Let's move on now to the call to presentations, and the first one is from Croatia. It's a SmartPortPloce, and the speaker is Robert Perenic, with business development and sales manager for Markolia. Robert?
Yeah, I hope you can hear me all very well.
Perfect.
Thank you. Thank you very much, Frédéric. I wish you all a very good day. I'm very glad to be here. I would like to thank in the first place the 5G Smart Communities platform for inviting us and giving us a chance to present a little bit of information about this project. My name is Robert Verenic. I work as a business development and sales manager in Marcoja, which is one of the 2 members of the consortium of the SmartPortPloce project, in which we will try to enhance public services that the Port Authority of Ploce is providing to its tenants through a private 5G network. So maybe we may move on, and I will try to give you, let's say, a snapshot of what we are trying to achieve and how we are hopefully manage to do this. To give you just a quick overview of some facts in a nutshell. So as I said, the project target is to give a level of automation to the Port of Ploce Authority in order to enhance their industrial processes and logistics capabilities with the aid of a new future-proof technology. The project consortium is a consortium of 2 entities, the Port Authority of Ploce, which is the main carrier of this project, and Marcoja, the company I work for, which is, let's say, if we can say, the technical support and the consultant in the whole project. The project duration is set to be 30 months, so we should be finished by June 2026. And the idea, of course, except deploying a state-of-the-art, future-proof network infrastructure, meaning 5G, with the use also of MEC, which will be fundamental to deploy the use case and to enhance the overall capability, industrial capability of the Port Authority. We aim to deploy 3 use cases in order to prove that the deployed infrastructure is really what we need for in order to enhance the overall process. The first use case is the introduction of the real-time location system in the area under surveillance of the Port of Ploce Authority. The second is surveillance and record keeping of cargo manipulation. And the third one is the incident prevention and management. The magnitude of the project is around 1.27 million euros with a CEF contribution of 960,000 euros. So we may move to the next slide, please. Let me just briefly introduce you the project member of this consortium. So as I said, the one is the Port Authority of Ploce, which is a public institution that is directly responsible to the Ministry of Sea Transport and Infrastructure of the Republic of Croatia. And it has the main task and responsibility for the governance, development, and utilization of the Port of Ploce area. So the Port Authority has a lot of, let's say, activity under its wing. And mainly we can list them as caring for the construction, maintenance, management, protection, and improvement of the port area, ensuring a permanent and uninterrupted traffic and technical and technological unity, coordinating and supervising all the concessionaires that are performing economic activities in the area of under their governance, and managing the free port zone and the overall port zone. So there are a lot of concessionaires in this area. Mainly, the biggest one is, of course, the Port of Ploce Incorporated, which is a private-owned company that basically is performing a lot of activities over there. Plus other entities, like it can be a logistic company, construction company. Of course, since the port has also a passenger area, there are the ones that are let's say taking care of the passenger lines. And of course there are public services as police, firefighters, healthcare, etc., that are concessionaires within the area, and that the Port of Ploce, the Port of Ploce Authority needs to let's say coordinate. On the other hand, Marcoja, the company I work for, it's a private-owned company operating in the telecom sector in Croatia since 1994. Briefly, we have 3 main business units. One is professional services for telco. The other one is related to automatics and sensorics. So basically measuring every kind of non-electrical value, turning them into data. And the thing that I'm mostly working with is the deployment of private 5G networks in Croatia and mobile telco infrastructure deployment. We had the luck as a company that our regulator, when the auction for 5G spectrum was launched here in Croatia, they decided to allocate a portion of the spectrum to so-called small operators on a regional basis. So our company, through 2 rounds of auction, we acquired a concession for 9 countries in Croatia, giving us practically an average 30% population coverage and a 50% territory coverage capability, with dedicated spectrum for 5G purposes. So we can move to the next slide, please. Just to give you a couple of main facts and an overview of the area and of the playground where we are. So the Port of Ploce is located in the southeastern part of Croatia, in the Dubrovačko-Neretvanska county, which is I would say the southernmost part, the southernmost county in Croatia. It's a port of outstanding national economic interest, as proclaimed by the government of the Republic of Croatia. And it has a position which is, I would say, pretty much strategic, as it is the endpoint and the start point in the Corridor 5C. The port, due to its very strategic position, is also very important not only for Croatia, but also for a part of Bosnia and Herzegovina, since a lot of traffic that goes over there passes through the Port of Ploce, bringing to also a cross-county coordination, even though Bosnia is not in the European Union at the moment. But I think also this is a very important thing to remark. We can move to the next slide. No, sorry, just a couple of more things regarding the port and how it looks like. The port, it's a port of universal purpose. So meaning it can transport, carry, and handle more or less all of type of cargo in international maritime traffic. The overall turnout is, let's say, around 5 million tons a year, and it has basically 7 distinct terminals. One, it's a new bulk cargo terminal. The second one is a container terminal. The third is a general cargo terminal. The fourth is the old bulk cargo terminal, a grain cargo terminal, a terminal for aluminium, coal, and petroleum, and a terminal for wood. So now we can move to the next slide, please. Why we decided to try to set up this project with the help of the Port Authority. As you may understand, the Port Authority is pretty much a complex and interdependent system. There are a large number of entities that operate within the port area, and the number of operation is very high, and there are a lot of diverse operation due to the requirements of each tenant in the port. So there are many shortcomings and bottleneck in the overall operational process. What we have identified as the biggest problem at this moment is an inadequate traffic coordination. The current situation and technology do not allow the Port Authority to control precisely, especially when it comes to the cargo traffic and the truck traffic, what is happening on their area. This yields to potential a lot of problems, meaning trucks not ending at the proper position, staying in parts of the port where they're not entitled to stay on, and so on. And especially since there can be that they are carrying some dangerous material, this brings also a pretty much serious problem to the safety of the overall area. The second part that we detected is that the actual IT and telco infrastructure is pretty much insufficient. Meaning that the integration of operation of all entities in the area is practically currently impossible with the present system deployed in the area. The third thing is that the port operation are organized pretty much in a reactive way, I would say. Just to make an example, cargo loading and unloading and tracking of the cargo is still done manually because no dedicated digital system is available in the area to optimize this kind of process. As I already mentioned, another thing that is pretty much tricky at the moment is the port security. which is insufficient due to insufficient surveillance system and the lack of technology that allows implementation of advanced system. And the last one, which is also of crucial importance, is the environmental and pollution issues, meaning that there are no resources and systems that are capable to track the air and sea quality at the moment. So as I said, most of the operational processes are handled in a reactive way due to the lack of proficient IT systems deploy and adequate telco infrastructure deploy at the moment. We can move to the next slide, please. Okay, so the idea of the project is to go towards a smart port. So to a port which autonomously can conduct operation and optimize processes, whether it is logistic or other kind, with applying a new advanced technology. So the main features would be management of technical processes, digitalization overall of the whole processes, increasing efficiency, integration of the port with the city, and the use of renewable energy sources. To address some of the issues that I have mentioned in the previous slide, at the moment we have detected that the 5G network is the only communication standard that at this moment meets long-term standards to fulfill and satisfy all the needs that the port can have, and is capable to replace the presently deployed system and integrate eventually some of the present IT and communication system within itself. The reason why 5G, I think we have a lot spoken about that also during the previous session of the 5G for Smart Community platform. So basically, it's a unique network, and what is mainly, in my opinion, the biggest trigger is that by the deploying MEC, mobile edge computing, we can have a very low end-to-end latency that will allow us to deploy advanced use cases which are data intensive and that require a very high response time. That with the current situation in the Port of Ploce, it's not possible. We can move to the next slide, please. So what are we gonna do under the CEF program? Basically, the first thing, of course, is to deploy 5G infrastructure and with the aid of mobile edge computing. There will be the deployment also and the demonstration of 3 use cases, which will help to enhance the operational process in the area under the authority, under the governance of the Port of Ploce. We have identified in this moment 3 use cases that will be, let's say, the most important, and that will have the major impact on the processes that are handled in the Port of Ploce authority. These 3 systems are the introducing of real-time location system, the surveillance and record keeping of cargo manipulation, and the incident prevention and management use case. So we can move on the next slide, please. And I will, within these cases, try to show you what the idea of the case is and what are our aim and our target in deployment of this use case is. So,
Robert, excuse me, you have 5 minutes more?
Okay, then I will try to speed up then.
Thank you.
Okay, so the first case, it's the real-time location system. There are 2 main segments that will be deployed under this use case. First thing, as I said, there is a very inconsistent traffic of vehicles within the port. So, and this is something that poses especially some security problems, and let's say trucks not finishing where they are supposed to be, etc., etc. So the idea is to deploy a system that will allow tracking of vehicle, where the specific vehicle is, to prevent vehicles to enter the wrong terminal, and overall the overall automatization of the whole traffic management in the port. The second part is regarding the seaside of the port, so geolocation of the ship, information about water, wave range, tides, etc., that will be all informations that will help the operators within the Port Authority to provide assistance for berthing, loading, unloading, etc. The key enabler of this will be to bring computational and services to the edge of the network to ensure low latency and faster response because of localized computation and decision making. We can move on, please. So the second use case will be about surveillance and the record keeping of cargo manipulation. The idea is, of course, to deploy sensor and smart camera that allow video analytics. As I mentioned before, most of these things are done manually at this moment, which will help to more efficient and accurate daily operation, accurate recording of data and data keeping, ensuring that each cargo is stored at the proper detention place, because now is the case that some cargo, which is wood, for instance, finish in the terminal of aluminium and so on. So this system will prevent to have this kind of incident. Another thing that will be very important, that will be deploying a drone with sensor and camera that will be able to recognize and keep record of bulk cargo and measure its quantity. So also here we will have a precise record keeping in terms of cargo and type of cargo quantity. One part will be the recognition of damages on containers or freights, encounters of entrances and exits of cargo objects in and out of storages. The acquired data here will be sent to a central platform operator via 5G network, which will allow much more precise record keeping of cargo in terms of cargo type and quantity, and to enhance the efficiency of the data processing. Overall, we aim to process a bigger part of all this data at the edge of the network. We can move to the last slide, I think, and this is the case 3 that we are aiming to deploy, which is incident prevention and management. Here there will be a lot of things regarding installation of fire detection sensors and thermovision camera, which will enable quicker and more accurate detection and response in event of fires. A drone equipped with a thermovision camera and other cameras that will identify fires that may arise and that will control pollution, especially on the seaside. And installation of local weather stations for measuring wind and humidity that will allow prompt reaction to pollution, whether it's due to bulk cargo or other type of cargo, and triggering some prompt reaction when some pollution risks may arise. All this data, since this is a fact that it's, let's say, regarding security, will need to be shared with the key stakeholders, as it is the fire department, the police office, and the ambulance, etc., etc. Since this data, we predict that this data will be, these cases will be very data intensive, and there are many stakeholders. Involved. What is required is a very reliable infrastructure and the prompt data processing and data sharing that must be ensured. And the last slide is just a few. We can please go to the next slide. As a conclusion, just in a nutshell, what are the specific objectives of the project? Enable leading edge connectivity, improve public services in the Port Authority, in the area of the Port Authority, optimize the work process, and enable large data share and analytics. And the main expected outcomes are, of course, the deployment of the network itself that will help us to deploy the use cases that I have just presented. Okay, and that would be it from my side. I wish to thank you. Hope I did not go out of time that much, and I will be more than glad to take questions in the Q&A if you may have one. Thank you very much.
Thank you very much, Robert, for detailing your 3 use cases with multi-access edge computing. So this is it was really interesting, and there are already questions for you for the Q&A session. Let's move on to our next speaker, and this is a Swedish project now 5G Edge enabled smart community for green transformation in the North project. And our speaker is Torbjörn Mindel. He is Director, Head of IC Data Center Unit at RISE Research Institute of Sweden. So Torbjörn,
Thank you.
15 minutes, please.
Yeah, thank you very much. Thank you for inviting us and the opportunity to present the project. Thank you also for getting the funding for the HEDA people that are here on the call. We are set out now to implement this. The project started 1st of January, and we are on our planning, startup phase, and procurement and things like that. Next slide, please. So this is kind of the starting point for the discussion for us. We in the team that finally sent in the application, we had one of these targets, the 10,000 edge nodes in our mind, because we see that a number of new use cases will be possible to support if we have low latency compute in the 5G network. Please, next slide. As I said, starting point is target, and since we see that the latency is going down in the mobile networks, it makes sense to deploy compute very close to the network edge. So we talk a lot about the network edge, not about device edge or regional edge, etc. We are involved in the Edge Observatory project to see how to monitor and define, monitor, and follow up the development in Europe of edge nodes. And what we see then is, of course, that if we get this type of technology implemented all over the network, it will support completely new applications that is very hard to implement today. But one of the things with edge computing is that it's not so much network edge computing available around Europe or in the world today. And of course, then if you're an application developer, you are thinking, okay, should I really develop this application for ports, for example? As we heard, if there is no ports to deploy it on, if it's only one place or so on, is it worth my investment to develop this application and get it up and running when there is no network? So there is hesitance among the developers. And if there is no applications or developers, of course, the network operators are hesitant to deploy edge nodes out in the network. So we have a catch-22 problem here, and it's very similar to what we have seen through the years with 2G, 3G, 4G, 5G, etc. rollouts. You need to go and start building in the midst of a lot of users and a lot of applications. So that is what we are aiming at here. Next slide. This is a little bit animated slide, but if you click one more time, not too far, please stop a little while there. So if you just shortly, this is the kind of a slide that describes why I got very interested in edge computing. I have been at Ericsson for a long time now. I am at RISE Research Institute of Sweden, and this project is together with Telia and 4 communities. But this is kind of a simple drawing of a network latency. So we have round-trip delays from the interconnect points of mobile networks and the internet. So we have the RTT down is the latency in the mobile network, and RTT up is the latency in the internet. So if you now go to the next slide, next step, animation. when we look back at GSM, I was part of a team that built the first GSM testbed once at Ericsson 85 when I started at Ericsson. And when we look at those delays, latencies, we could see that, okay, the mobile network 250 milliseconds and the internet, depending how far away you are from something, they have 10 to 40 milliseconds. So there is the main latency for applications is from the mobile network. But if you go next animation, but now with the promises of the specification of 5G advanced, etc., we see below 5 milliseconds as an opportunity. Currently in the network we are researching on, we can see just below 10 milliseconds on the mobile network delay. So here, of course, it's the main latency is from the internet. If you compare the latencies here, so then if you click on the animation, please, then it's really a great opportunity to put edge compute very close to the equipment and to the end users, but in the mobile network. So you can do offloading or move compute closer to the end user. And so this is the main reason why this is very interesting opportunity to develop a completely new type of applications that can support new use cases. And so if you click next animation, and if you then take the delays from the different generations of mobile networks and put them in a table like this, you will suddenly notice that, okay, it's an exponential change in the latency. And usually when there is an exponential change of something, it usually means a great transformation or even sometimes it has been revolutions depending on in the technology domain, if you have an exponential change of something. So this is why this made us very curious to do something together with Telia. Okay, next slide. So what type of use cases are we talking about then? I have two examples here. We have been working with a company that do a navigation tool in mines. The underground mines can be used in tunnels or different kinds. And in a mine, in underground mine, there is a lot of roads, a lot of tunnels, and the speed when to update the map, for example, to coordinate all the traffic down in a mine needs to be really fast. And what they did was to develop a very advanced machine learning algorithm to do all these graph combinations to draw this map. With the latency from the cloud, it was too slow updates of the map, which could be dangerous. So instead, they implemented that on the iPad or on the phone, but with the limited compute capacity on an iPad, for example, they had to cut down on the algorithm so it doesn't work as good as it could work. So with the compute, we haven't yet put that compute in that mine, but we are on the way to do that. But if you put compute in the mine very close in the 5G network, the compute of this algorithm could be done in that node. So this is one example. If you go to next. The other example we also have been working on and that we're going to continue with in this new project, 5G Edge project, is using the drone for detecting persons in a mine. So this has been a couple of projects or towards mining in the mining industry. But anyhow, this can be used in other cases as well. So the idea here is to move the compute away from the drone. So all the battery and the weight is moved away. And then the battery can be larger and the other weight can be moved away. And in that way, the drone can fly longer. And it is supposed to be used in dangerous situations to detect persons. So this is another type of edge application that is completely new and possible to do with edge compute in the 5G network. Please, next slide. So we, together with Telia, decided that we were going to try to apply for some funding to start building some new places in a number of communities. So we in the project, we are using Telia's 5G innovation network, and we are using RISE Cloud Edge Continuum compute nodes and software platforms. Next slide. In the Edge Observatory project where we are active, we have been working on the definitions of edge and where the different nodes could be. And in this table, we could say that we are aiming on far edge and on-premise edge. That is where these type of application, these implementations will be. Okay, next slide. We have, during the last years, worked on different types of edge nodes that can be used in this setting. So to the left are bigger ones, more regional edge, aggregation edge, and to the left, smaller edge nodes, which could be the compute out in the 5G network. And the interesting thing is that, okay, do you really need that high-end compute in the edge, on the edge? And what we have seen is that when the latency go down in the network, and you have a lot of compute, and you do the compute close to the devices, the latency introduced then comes from other places. And for example, the camera latency is suddenly important, and the compute speed is important. So if you have a slow server in the edge node, it will take too long time to compute, and you introduce latency there as well. So you need advanced edge nodes, low latency networks, and really fast equipment out in the devices to get down in latency down to 5 milliseconds or close to that. Next slide. So the project we have got funding for is the 4 places on the top there, Luleå Port, Luleå Harbor, as one use case, place for use cases, Boden Industrial Park, Skellefteå's North City, Ultuna Smart Agriculture Site. We have also sent in another extended applications for 3 new sites for car winter testing, UAV testbed, and mobility testbed in Borås. Continue, please. Sites we have got funding from, so it is a port where we're gonna look at different use cases, industrial park, a smart city, and the smart agriculture site. Next slide. And these are the use case areas that we're gonna look into and try to develop new type of applications. So safety in the Luleå port, smart waste management in Boden, traffic management in Skellefteå, transport in logistics in Luleå port, and smart agriculture in Ultuna agriculture testbed. Next slide, please. From RISE side, which is the Research Institute of Sweden, we are offering our Cloud Edge Continuum with nodes and software packages up to infrastructure layer. So on top of that, we can develop new applications. Continue, next slide. And Telia, as a network operator partner, is deploying what they call the 5G North Star Innovation Network, which is not yet commercialized Ericsson equipment. So it's latest features involved in that innovation network, and where Telia can try new technologies together with Ericsson. And that will be deployed in these 4 new sites. Next slide. And in parallel with this, we are working in another project called Nexus Forum, where we, of course, take all the learnings from this, and we are trying to write a research and innovation roadmap to support the development in EU, and there is a number of areas there that really needs more attention to improve this cloud edge continuum technologies to make this new type of application to enable them and make it to happen. Next slide, please. So maybe it's not Q&A right now. So thank you very much. That was the presentation from the 5G Edge project funded by the EU HADEA and with the partners Telia, and 4 communities, as mentioned, cities in Sweden: Luleå, Boden, Skellefteå, and Uppsala. Thank you very much.
Thanks a lot, and thanks for explaining how latency can be reduced in the use cases you are developing in your project. The last presentation for this morning is from T-Systems. So T-Systems is an IT service provider providing cloud services, digital solutions, security, and connectivity. And our speaker this morning is Gabriel Velicka. He's manager for edge computing cloud services. Gabriel, the floor is yours.
Okay, thanks a lot. Can you hear me?
Yes, perfectly.
Okay, wonderful.
Okay.
So thanks a lot again for the short time slot which I have left to basically bring you near the edge computing, what we do in T-Systems and how we developed it based on customer feedbacks, and more focusing on the industrial part of edge computing, because I heard a lot of projects and approaching projects from the public sector, from the speakers before me, and thanks a lot also for the introduction of edge computing, because then I can basically talk fewer words about the introduction. So basically it was already mentioned what edge computing is. Only I would focus on the far edge, on device, far edge campus, and near edge, basically the names derived with the distance from the cloud or enterprise data centers. And in today's short presentation, I would bring you near the far edge campus and far edge on device, which we developed for customers. Yeah. Sorry, yeah, there it is. So why we go on with the systems into the edge computing, and what were the most or the pain points for the customers which we try to identify, was the geographical availability, for example, which comes in hand really with the regulatory requirements, for example, smelting steel, yeah, or some companies which we cooperated with, which have data which cannot be hosted on the hyperscalers. So that's one reason. The second one is bandwidth. We saw that many times the companies don't have sufficient infrastructure, yeah, so meaning they cannot migrate to the cloud, yeah, rather go really edge-wise, where the bandwidth on the LAN is much better. Yeah, limited autonomy, meaning the customers really have the workloads which are really crucial for them. For example, as mentioned, the smoldering facility, where if you would lose the connectivity to the process, then very bad things could happen. Yeah, so this is also addressed with our solution. Last but not least, the speed, latency, critical workloads, which I will be also mentioning later on, where we implement directly our edge solution with the 5G core of telecom. So how we do it in the systems, we rely on 5 pillars. The autonomy, as mentioned earlier. Our systems or the solution needs to be functioning also during a network outage, during a WAN outage, also when our administrators don't have access to the deployment or to the cluster, then the IT staff at least the IT staff of the customer needs to be able to provide support for the customer, where the workloads are still running and not affected by the outages. And features which I would like to highlight on this one are basically the local control plane, which the customers can use to basically check for their workloads, also on-prem backups, and manage Kubernetes. Another aspect is the, sorry, I always misclick, the latency and bandwidth, which was already mentioned before by the previous speakers. I also do really strongly agree with the aspect that not always the latency is the king, but rather the bandwidth. Yeah, and we came along and many industry partners identified these problems, that the latencies are okay, but rather the bandwidths which are provided are insufficient. So to address this one, the storage networks were introduced to the customers. Yeah, so reduced distance come in hand. So local processing, that's natively for edge computing. Further, I would mention network segmentation, and for example, one feature, the SRIOV, which basically provides the so to say, full scale of 5G or fast networks to the virtualized appliances, meaning ignoring the hypervisor level or the virtualization level software, yeah, which is slowing down the network. Resiliency. Basically, we are hardware agnostic, so basically customers are not affected during outages from other vendors. High availability comes in hand with the 3-node deployment. Basically, customer can deploy on the whole campus. Adjustable data replicas, external file system backup options paired together with hyperscaler options, so meaning they can back up also on hyperscalers, also on tape and so forth. And disaster recovery volumes, which Kubernetes is providing. We can also make disaster recovery from those volumes, yeah. So for security, data sovereignty comes in hand when the deployment is done on premises at the customer sites, and that's a big advantage for the customers, and that is also really asked for from the customer, that the data resides on their premises. DTPSA standards, really tight security standards of Deutsche Telekom, which are implemented in each of the products from Deutsche Telekom, but especially today I'm speaking about Edge Air. So also we are PSA approved. Rule-based access control, multi-tenancy, physical security comes in hand also with the deployment on the customer side, and trusted platform module if the customer wishes for, meaning if someone steals the disks from the customer, he cannot decrypt the data which is on those disks. And versatility, here I would like to focus more on enabling 5G application use cases, either as a satellite worker or workload, basically hoster. I can maybe tell it on a small example which I mentioned earlier, where we deployed exactly our edge solution besides the Telecom 5G core, and the customer was enabled to basically provide his end customers with the full spectrum of 5G, the low latencies, and all the use cases which the customers would like to test in the virtualized environment. Yeah, so. And these are basically the two solutions which we can adapt to the customers. The first one, the campus one, is basically the far edge campus solution, consisting of 3 nodes running HCI harvester from SUSE. And the second one, the smaller one, the embedded, is basically a ruggedized device which you can, for example, use in harsh environments, also put onto robotic arms and so on and so forth. Both solutions are, as mentioned, hardware agnostic, x86 architecture. And with the last slide, I would like to showcase where we are maybe not maybe, but where we are located in the ecosystem of the Deutsche Telekom. As I mentioned before, we are consuming the 5G networks from the telecom colleagues or any other provider. We are the landing platform for be it customer use cases, customer deployments, or in this case, in this slide, for the applications and products developed in-house by PU Digital. And therefore we can accommodate basically each customer requirement vertically. So, and the end-to-end security is standard for us. So thank you very much for this short time slot as mentioned. And if you have any questions, anything which you would like to ask, then please write me or address your questions now. Thanks a lot.
Thank you very much, Gabriel, for giving your IT perspective Edge Cloud. It's very interesting to see how the IT and telecom worlds merge with 5G. We now have time for a few questions. So I noted a first question for the European Commission. It's from Francesca Macri. She would like to have an update on the ongoing projects and the new one, and if new ones will be launched soon. So I would ask our EC colleagues maybe to answer on this, on when Call 3 results will be published. I think maybe Christian Milla is connected today. And while Christian connects, you have a questionnaire here on the chat, so please answer this Slido questionnaire.
Yeah, good morning, Frédéric and all. I'm not sure I understand who your question originates from. And you mentioned Call 3, so the question is about when the result of Call 3 will be made public. Is that correct?
Call 3 is not mentioned, but I read it. I would like to know where there will be the final approval on the ongoing projects. So I guess it's Call 3, and if new ones will be launched soon.
Okay. So I'm turning to. So this is with our colleagues from HDA, the Health and Digital Executive Agency. I know one of them is participating in the call. So what I can share is that we are currently in the middle of the evaluation of the different proposals received so far. But with respect to the calendar, I don't have it with me, and I would appreciate if a colleague from HDA could give me a hand on this. Otherwise, I will come back on this specific question.
Okay, thank you, Christian. Now we had a question for Robert Perenich for the first project. It was a question on the real-time location and how accurate is it, and is RTK GNSS used?
I didn't. Sorry, I didn't catch you very well. I had some breaks, so if you can repeat the question.
Okay, so this question comes from David Vermeulen, and I think it was for the first use case. How do you do the real-time location system, and how accurate is it?
That's something that will be proved during the deployment of the project. How accurate is it? So basically, let's say we are here talking about. We are not talking about the accuracy in the terms of centimeters here, if this is the question. I mean, we are talking about traffic. So basically, in terms of accuracy, how to say, we do not need to have an accuracy on terms of 10 centimeter, 15 centimeter of stuff like that. It's more or less positioning within the space.
Okay, thank you. We have a question from PTS. How will 5G MEC relate to federated cloud initiative? Any views on how safe funding for cloud infrastructure would be best beneficial for the 5G MEC? So who would like to answer this question?
Yeah. So we, of course, we plan a very broad collaboration with all relevant initiatives. And of course, cloud infrastructure plays a very critical role in the deployment and functioning of 5G MEC. Of course, in the context of enhanced data processing, resource optimization, for example, or even service agility and scalability. And of course, also like application and service hosting. So cloud infrastructure supports the hosting of application services directly at the edge of the network. So this is also very relevant for us. And at some point, of course, we are right now in the ramp-up phase. At some point, we will also have a very detailed discussion with all relevant cloud initiatives to discuss how our projects, how our initiatives can contribute to really implement a very diverse and very deep-rooted 5G network, 5G MEC network in Europe.
Thank you very much, Dimitri, for your answer. I think Elena Gennaro is online. Elena?
Yes, thank you, Frédéric. Just to reply or to complement to Christian before, the results of call 3 would tentatively be published in summer, so August or September. And the call 4 is going to open in principle in June, but it depends still on the work program 2 that is currently being finalized, if I understand correctly. That I think Christian can complement on that.
Thank you very much, Elena. Christian?
No, I don't have any details to add on this calendar issue.
Okay.
Yeah, what I could say is that for the time being, we are currently into the preparation of the second work program for Safe Digital that will be covering the remaining period of Safe Digital. And so we are current, and on this basis, the calendar for the remaining life of Safe Digital will be adapted, taking into account any possible, I would say, orientations or shift in the objectives on the way. With that, I'm in particular referring to the digital connectivity package. It's a new initiative that was presented by the Commission in February, on the 21st of February, which is about a set of possible actions to foster the innovation, security, resilience of digital infrastructure, and that set at the core of it precisely this integration of cloud edge infrastructure. And in that respect, goal is to, I would say, foster, encourage the development of ecosystems that will bring market players from or stakeholders from the different sectors. And I think with the 5G smart communities, this is precisely where one of the ambitions. This is also the case with the 5G corridors that aims at supporting the deployment of connectivity infrastructure and connected and automated mobility in particular. In that respect, I would add that to reach this goal, the Commission in its white paper presented the approach based on the creation of a connected collaborative computing network, precisely to set up end-to-end integrated infrastructure and platform for telco cloud. So this is broadly the orientation, and we are currently working on, so we say, the implementation, and that will certainly will be also so we say translated into adaptation of the current work program and for the in view of the second work program for Safe Digital. Thank you.
Yes, maybe just to, I'm not sure it was clear. So the results of call 3 will be in August or September. And then the call 4 was tentatively foreseen for June, but it depends on the approval of work program 2. So it can be be postponed in line with what Christian just explained.
Okay. Thank you very much for these clarifications. We have time for one last question. I think it's quite important. Would you agree that latency, when stable, is not a big issue, as this can be corrected by software? And the problem is more jitter, so the variance in latency, that is the real challenge. So there was already an answer by Torbjørn Minde in the chat, but maybe Torbjørn, you could come back on this, because I think it's quite an important question here.
I can follow up, because even when we add this edge computing, the sort of main problem is not like the delay between the 5G system and the edge computing, is the variation of the delay on the radio link, and fixing that is a bit not that easy to do, because it's very unpredictable, even depending on the different frame structure on the radio and whether it's a type of access granted. So there's a predefined slots. So this delay variation is problematic.
Okay, thank you, Torbjørn.
Yeah, of course I agree with that, but it depends on the application if the latency is really important. Because some applications will not be able to run without super low response time. Like if you have these new type of glasses and you want to run them with camera and screens and things, and you want to run them on the network. When you turn your head around, you need precise positioning and you need precise, very short latency to not get dizzy. So useful, even it's not useful otherwise. So, or other, like the drone application I was talking about, you need a real-time decision back to the drone. So where every millisecond is very important. So an application, most application probably that we know of today, it's not so problematic, but this will enable a new type of applications we haven't seen before. Okay. That's my input.
Okay, thank you very much for your answer. So this is the end of our capacity building session today. Thank you very much to all the speakers today. And for the participants, so you will be able to find the videos and the PowerPoint presentations on our website on 5gsc.eu. So thank you very much for your participation, and see you in June. Bye-bye.
Okay, thank you.
Thank you very much.
Bye.
Thank
you.
Thanks.
Bye.